Good morning, fourth graders. Today we're on page 75 of our student journal, page 75. And today I'm actually going to be using some crayons. So in addition to my pens that represent your pencil, I'm going to be using a couple crayons. It would be helpful, I'm going to have 3 colors, but it would be helpful if you at least just had 2 different colors. So if you want to pause your video and get 2 different colored crayons, that would be helpful for today. You'll also be using them probably in your next lesson as well. Okay, so our goal today, or our objective is, today I will add fractions by joining parts. Okay, so that's our goal today. Today I will add fractions by joining parts. So let's look at some of our key vocabulary today. So we have, our first 2 words are numerator and denominator, the 2 parts of a fraction. So the first one says the number of equal parts being considered. So that's our numerator right here on top. So I like to think of the numerator as what I have. So I have this. The denominator is the total number of equal parts in the whole. So how many has the whole been cut into or divided into or split into? Those are words that I think about. So when I see 1/4, I think I have 1 out of the 4 pieces. So a cake or a pie was cut into 4 pieces and I have 1 of the 4 pieces. Okay, they also show us a representation of an equation. So they have 2/4 plus 1/4 equals 3/4. What I want you to really notice here is look at the numerators. The numerators are 2 and 1, and look what they did to them. 2 plus 1 equals 3. But look at the denominators. They never added them. So the denominators are not added. They only added the numerators. That's a really important thing with adding fractions. Okay, let's look at our steps. It says we're going to represent the fraction equation with a visual model. So today we're going to be using number lines and kind of like area models in a way, visual models. Then it says find the sum is an addition word, of the fraction equation and visual model by adding only the numerators. Key phrase there, only the numerators. When we only add the numerators. Okay, so I'm going to show you what this looks like, boys and girls. Here is my first problem. My first problem says 1/8 plus 5/8. Okay, so 1/8 plus 5/8. Okay, so my first step said I'm going to represent the equation with a visual model. So for this one, I'm going to use like an area model. I'm going to use circles. So I'm going to say 1/8. Okay, when you divide or partition means cut or divide, you make sure for circles, you always go through the center. So the 8 denominator tells me I need to cut this into 8 parts. So I'm going to cut this into 8 parts. But when you partition it, make sure you go straight through the middle. And you can double check if you did it correctly. 1, 2, 3, 4, 5, 6, 7, 8. So the denominator 8 says I have cut it into 8 parts. The numerator 1 says I have 1 of the parts. So I just have 1 of them. That's it. So I'm going to say I have this one. So I would say I have 1 of the 8 pieces. 1 of the 8 pieces. Plus 5/8. Okay, so again, when I partition circles, I have to go through the center. 8's kind of an easy one to partition it into, though. Okay, so I have 5/8. I'm going to use a different color for this to show you. So I'm going to say I have this one, 1, 2, 3, 4, 5. So I have 1, 2, 3, 4, 5 of the 8 pieces. Okay, so what does this look like now? Well, if I put those together, think about like if you had pizza left over from a party. Some of you have probably had a whole bunch of boxes of pizza, and at the end of the party, your mom throws it all in one box instead of trying to put a whole bunch of boxes in the refrigerator. I know my kids get mad when their good pizza gets mixed with my pizza that they don't like. But so if I combine these and add them, I would put this piece over here, and then I'm going to put these pieces over here. So 1, 2, 3, 4, 5. So what do we now have? What's our total? Well, our whole is still only cut into 8 pieces, but how many pieces do we have now? 1, 2, 3, 4, 5, 6. So our answer would be 6/8. So this should show you why we don't add the denominators. Our denominators don't get added. We're just taking what we have of numerators and putting them together. Okay, I'm going to show you another one, but I'm going to use a different method. I'm going to show you a strategy with a number line. Okay, so here I have 2/6. Okay, so I'm going to take a number line, and here's my number line, 0. And my number line is going to go to 1. Okay, so 6 means it was partitioned or cut into 6 pieces. So I'm going to do it in half. And then, see, I have 1, 2, 3, 4, 5, 6 sections. So that would be 1/6, 2/6, 3/6, 4/6, 5/6, and 1 whole is equivalent to 6/6. Okay, so 2/6 mean that I went right here. I jumped 2/6. Okay, plus I have 3/6. So I'm going to do the same thing. The 6 on the denominator tells me I need to divide my whole one into 6 pieces. So 1/6, 2/6, 3/6, 4/6, 5/6, and 6/6. So 1 whole is equivalent to 6/6. And this time they went 3 pieces. So they went all the way to 3 pieces. So I had 2/6 plus 3/6. Now when I put those together, if I took those together, I still have a number line that's cut into 6. So I have 1/6, 2/6. Make sure you can see that, boys and girls. I just realized that. I'm so sorry. Let me zoom out a little bit so you can see that better. Okay, so I have 1/6, 2/6, 3/6, 4/6, 5/6, and then 1 whole is called 6/6. Okay, so if I put this together, my first jump was 1, 2, and then I jumped 1, 2, 3. So 1, 2, 3. So I did a jump of 2 and then a jump of 3, and look where I end up at. I end up at 5/6. So again, my numerators get added, but my denominators don't. So I know I liked the other method better. I liked drawing better than this, but we're not always going to have a choice, boys and girls. Sometimes they're going to tell us you have to do a specific one. Okay, so let's do some of these together. We are on page 76, and here's our first problem. It says 4/8 plus 3/8. Okay, so remember when we do when we do circles, they always have to be partitioned through the center. So make sure we partition through the center. Okay, to cut it into 8ths, I think the easiest way is to go in half. Go in half again, which makes it 4ths, and then go diagonal and diagonal. And that should give you 8 pieces. Okay, so I have 4 of them. So let's all try and shade the same ones. So I have 1, 2, 3, 4. I have 4 of the 8 pieces because the denominator 8 says 8. Cut it into 8ths, and the 4 means you have 4. Okay, the next one is 3/8. So let's cut this up into 8ths because my denominator is an 8. And let's try and shade the same ones again. Okay, so This time it says we have 3 of the 8. So I'm going to shade this one, and that one. Okay, so let's think about our pizza boxes. Let's shove all these leftover pieces into one box. We're going to add them together into one box. So let's first partition this. And then I'm going to take these 4 and put them over here. And then I'm going to take these 3 and put them over there. So when I add them together, what do we end up with? We still have a whole that was partitioned into 8 pieces. But how many of the pieces now do we have? We have 1, 2, 3, 4, 5, 6, 7. So our answer is 7/8. Okay, let's look at another one. This time our equation is 2/5 plus 2/5. Okay, so the denominator 5 means we have to partition our whole 1 into 5 pieces. So just do your best. But then afterwards, I like to count them. So I'm not counting the lines, I'm counting the parts. So I have 1, 2, 3, 4, 5. Okay, so this would be called 1/5, 2/5, 3/5, 4/5, and 1 is called 5/5. It's one whole. A whole is when you have the numerator and denominator the same. It's equal to 1. Okay. So 2/5 means I jumped from 0 to 2/5. I just jumped 2 spots. Okay, over here our denominator is 5, so we have to do the same thing. We have to partition it into 1, 2, 3, 4, 5 sections. And this would be 1/5, 2/5, 3/5, 4/5, and 1 is equivalent to 5/5. So 2/5 would be, again, just jump 2 parts. Okay, so our answer is we're going to have to partition this into fifths. So 1, 2, 3, 4, 5 parts. 1/5, 2/5, 3/5, 4/5, and 1 is equal to 5/5. Okay, so if I have a jump of 2 plus another jump of 2, where do we end up at? We end up at 4/5. Okay, so that's what that's showing us, is they want us really just to understand that we're adding our numerators and not our denominators. Okay, boys and girls, have a wonderful day, and we'll be practicing this again tomorrow. Bye-bye.